In this video, we are going to go over the quotient rule. It's another one of these derivative rules, and once again, it's not too bad as long as you're careful with the algebra. So let's get into it. You're going to use the quotient rule when you have, well, the quotient of two functions, right? One function divided by another function. So here's the formula for it. The derivative of f of x over g of x equals g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now that's kind of complicated. So in calculus we use this shorthand, and that shorthand is low d high minus high d low over low low. What does that mean? Well, let's break it down, right? So we have our numerator and our denominator. So the numerator, since that's on top, that's our high. And the denominator, since that's on the bottom, that's our low. So the high in this case is f of x. The derivative, so d high, is f prime of x. Low is g of x, and d low is g prime of x. So that's all you need to remember. Low d high minus high d low over low low. As long as you keep that straight and are careful with the algebra, these problems really aren't that bad. So let's do an example. Our first example tells us to find f prime of x, where f of x equals cosine of x divided by x. And now you might be thinking, you might say to me, hey, I know that cosine of x divided by x is also equal to cosine of x times x to the negative 1. So I could use the product rule here. And that's right, you could use the product rule here, right? There are a bunch of different ways to solve these problems. But this is a video on the quotient rule, so we're going to use that. And we know we can use it because we have one function, cosine of x, divided by another function, x. So let's remember our formula. Low d high minus high d low over low low. Okay, so what is high? Cosine of x. D high is just the derivative of that, which we know to be negative sine of x. Low is just our denominator, so x. And d low is 1. So now we have all the pieces that we need. So now we just plug everything in, right? Now it's just algebra. First we have low d high, so that's x times negative sine of x, minus high d low, which is cosine of x times, well, 1, all divided by low low, or x squared. And just a little bit of algebra gives us that f prime of x equals negative x sine of x minus cosine of x, all divided by x squared. And that's it. That's the derivative. Let's do another example. This one tells us to find the derivative of 3 minus 2x minus x squared divided by x squared minus 1. And so we know this to be the quotient rule, right? Because we have one function divided by another function. The quotient rule is a pretty easy one to identify. So let's remember our formula. Low d high minus high d low over low low. So high is the numerator, so that's 3 minus 2x minus x squared. D high is just the derivative of that, which is 0 minus 2 minus 2x, which equals negative 2 minus 2x. Low is the denominator, which is x squared minus 1. And d low is just the derivative of that, so 2x minus 0, or just 2x. So again, we have all the pieces we need, right? We've done the calculus. Now it's just algebra. Again, we start with low d high, which is x squared minus 1 times negative 2x minus 2 minus high d low, which is 3 minus 2x minus x squared times 2x, all divided by low low, which is x squared minus 1 squared. And now we simplify this to negative 2x squared minus 2x cubed plus 2x minus, in parentheses, 6x minus 4x squared minus 2x cubed, all divided by x to the fourth minus 2x squared plus 1. I don't know if that actually is much simpler, but we keep going, and we distribute that negative all the way through, and we get negative 2x squared minus 2x cubed plus 2x minus 6x plus 4x squared plus 2x cubed, all divided by x to the fourth minus 2x squared plus 1. And now we do take that one step further, and we get that the derivative is 2x squared minus 4x plus 2 divided by x to the fourth minus 2x squared plus 1. That's it, right? That's our answer. And so you see here, the actual quotient rule isn't that hard, right? It's just identifying the high, low, d low. That's really as hard as it is. The way they make these problems harder is they just make the algebra more complicated and convoluted, right? And so if you're confident in your algebra, these problems, they're really not that bad. Just take them slowly. Just that negative, the minus high D low, right? Make sure you're careful with that. You have your parentheses. Make sure you distribute that through, and these problems will work themselves out. Just remember, they're just to make the problems harder. They're just going to dial up the algebra on you. All right, final example. Find h prime of t, where h of t equals t plus 1 divided by t cubed plus 2t plus 2. And I know what you're thinking. You're thinking, whoa, wait. H and t, I work with f and x, right? Like I don't know how to do h of t. Just don't worry about it. Pretend it's an x. The same rules still apply, right? So just pretend that the t is an x and just take h prime of t as you would f prime of x. Let's remember our formula. Low d high minus high d low over low low. And let's get all of our parts. High is the numerator, so it's t plus 1. D high is the derivative of that, which is just 1. Low is the denominator, which is t cubed plus 2t plus 2. D low is just the derivative of that, which is 3t squared plus 2. Now, all we have is algebra. So let's just plug this stuff in and simplify, and then we'll be done. We start with low d high, which is t cubed plus 2t plus 2 times 1, minus high, which is t plus 1, d low, which is 3t squared plus 2, all divided by low, which is t cubed plus 2t plus 2, in parentheses, squared. And now we just simplify. And technically, if you stop right here, this answer is not wrong, right? This is the derivative, right? This is h prime of t. If you plugged in a t, you get the slope of the tangent line to h of t at that t, right? This is not wrong. It's not the most simplified form of the derivative, right? We're going to get to an answer that's a lot more simplified, but this technically is a derivative. So if you get here, you'll probably get most of the points in your homework or on a test because you've done the calculus part, right? This is a derivative. From here, we're just simplifying it. So as long as you can get here, you'll probably get by okay. With that being said, it's good to do the algebra and get the most simplified form because that's how you'll get full credit. So we're going to do that. This gives us t cubed plus 2t plus 2 minus, in parentheses, don't forget those parentheses, 3t cubed plus 2t plus 3t squared plus 2, all divided by t cubed plus 2t plus 2 squared. So we distribute that negative through, and we get t cubed plus 2t plus 2 minus 3t squared, or 3t cubed minus 2t minus 3t squared minus 2, all divided by t cubed plus 2t plus 2, in parentheses, and that's all squared. Whew, okay. Final step is we get that the derivative is negative 2t cubed minus 3t squared, all divided by t cubed plus 2t plus 2, in parentheses, squared. And that's it. Like I said, these problems, the calculus part is pretty straightforward, right? You get high, low, d low, you're done, right? It's the algebra where it's probably going to trip you up, and that's how they can really make these problems more complicated. They just make the algebra more messy. So as long as you work slowly, meticulously, and are very careful with your algebra and don't let it fluster you, you'll be fine. You really will. Just make sure you're careful with that negative and you distribute it all the way through the parentheses. One thing you can do, if you're not sure if you did the algebra correctly, is you can take your final answer and you can compare it to your initial answer right after you plugged in high, low, d low. Right after you plugged all those things in, and pick a t, right? Pick a random t, plug them in both cases, and see if you get the same answer, right? Like maybe t equals 0, right? In my final answer, if I plug in 0 for t, do I get the same thing as if I plugged in 0 for t at the beginning, right? If I don't, make sure I plugged in 0 right? Make sure I plugged it in correctly, because that'll make a difference. But if I did plug the zeros in correctly, and I'm still not getting them to match, then I made a mistake somewhere. Again, it's probably on that negative. We probably didn't distribute that negative. Or maybe it didn't FOIL correctly. But that's a good kind of quick way to check yourself and make sure that you're solving these problems correctly and that you didn't mess up somewhere in the middle. With that being said, If you liked this video or if you found it helpful, please like, share with your friends, subscribe, and I will keep the math content coming your way.